Good morning, good afternoon, good evening, wherever you are, and welcome back to the podcast that highlights innovative mobility solutions and the people behind them, the ways we move. I am your host, Nicolas Zart, and I've been in this industry for 20 years. I've had the privilege of meeting a lot of people. I've worked both as a consultant and a journalist. And so today I have someone I've been wanting to get on this podcast for a long time because I've known him for a few years. And also, I've seen the company develop for even longer than that. And it's a company you might have heard of before. I don't know if this looks familiar. If you've ever seen this eVTOL, imagine it has, a bunch of propellers here. And actually, that would be the right way to, that would be exactly the right way it's supposed to be. It's Pivotal. And we got to talk to Ken Karklin, who is the CEO of Pivotal, who also talked a little bit about what he did before and how his experience at AeroVironment was very important for what he is doing now with Pivotal. We've covered a lot of things. I'll let you watch the video, but please like, share, and subscribe. Also, leave comments. That's always very helpful for us to understand what is interesting to you. And again, the call to action is: has your view of AAM, Advanced Air Mobility, has it changed? Has it evolved? Do you know a little bit more? Do you feel like you maybe have an answer that you would like to share with us? Don't hesitate to leave your comment in here. Like, share, and subscribe. Without further ado, let's have Ken introduce himself and see what we're going to talk about. It's pretty interesting. So, Ken, please introduce yourself. Who is Ken?
Nicholas, good morning. Ken grew up an East Coast kid, and I'm certainly a nerd at heart. I've been in technology for 30 years, all here in the lovely state of California. I've been with the company, been with Pivotal now for 3 years, almost to the day, which is certainly hard to believe. But prior to this adventure, I was with a little company called AeroVironment for about 13 doing everything from program management to engineering management to running one of the two SEC reporting segments, divested one of their businesses, ran operations for the last 4 years. I met this wonderful guy named Alan Eustace. He's actually our chairman. And he told me I needed to go check out BlackFly and go meet this guy named Marcus Lang, who's the founder of the company. It was then called Opener. One thing led to another, and it turns out he was participating in a process to, move on to his next great engineering adventure. And I found myself running an integrated program team of less than 100 people for the first time in a dozen years, and it's been a delight.
Yeah, and in a somewhat similar kind of industry, because I'm sure you've learned a lot of things with AV when it comes to charging and everything. How has that been relevant to what you're doing today? Because you don't use the same kind of charging potential that probably AV is used to working with. So how does that work well together?
But actually, AeroVironment was a huge pioneer in the electric vehicle and electric vehicle charging infrastructure space. And that spanned not just the early EVs and more recent modern EVs, but it also included industrial charging. So, for material handling equipment, for trucks, it included ground support equipment at airports. So, anywhere you go where you get to walk on the apron and walk out to the aircraft, look over your shoulder, you see a big gray box that says Posi Charge on it. That's actually AeroVironment's equipment.
That's right.
It's, believe it or not, and I did not expect this, highly relevant to the aircraft that this company has built, because we're actually leveraging a lot of the same core technologies that exist in the industrial charging space and have similar battery voltages.
That's true. Yep. Yep. Yeah, it's true. I think AV, I think most people should know, if they don't know, that AV actually powers a lot of the aircraft where you take off and everything. And when you need to power a 787, you know what you're talking about, right? I mean, that's a doozy of a
Well, a little less so
powerhouse.
the powering the shore power for the aircraft, and much more so all that handling equipment. So, the baggage belts, the pushback parts, all that electric stuff, all powered by Posi Charge. And in 2018, I led a process to divest that business, and it was ultimately picked up by a 100-year-old private German tier one automotive supplier, which is the kind of parent the business needed, as AeroVironment was very focused on building out more autonomous systems, robotics, very defense focused. And, to be in the EV charging space and that is two very different businesses. And fortunately, we found a company that really wanted to acquire it and make it its growth story. They've been in, roofs and heaters for 100 years almost in automotive, and it's worked out very well for them.
Yeah, it's true. I remember in 2008, the three big names I remembered were it was of course AeroVironment, but Eaton and Schneider were the big ones when we talked about EVs back then. So and knowing where they came from, I was like, well, this is like chump change for these guys, fast charging, ha ha ha. But now we're talking about mega charging over here, and it's like, well, they can handle it too, so that's not a problem. So more so about what we now call pivotal, which once we used to be opener. Tell me a bit about what you found and where you are today, because it's light years away differences and everything. Tell me a little bit about the transition here, because you've done some spectacular work with the company.
I mean, the company's come a long way, and it was a kind of serial prototyping and testing operation. When I joined, pulled back the wool and showed the world a little bit about what the aircraft and technology is all about. Still had some way to go to make everything market ready, and we're still on that journey, frankly. But we were able to get things to a point where we would be ready to go with some early defense valuation, with some early access by private customers who we could work with to help us develop the training, to help us develop customer support, and who were ready to potentially deal with any flight restrictions we might impart, because BlackFly is in fact a developmental aircraft, although it's on its third and a half generation in development for over 13 years.
Yeah, that's true. And so you guys chose light sports, which I guess makes sense. Tell us a little bit more about this and your plans for the future, if anything should evolve.
Well, yeah, not so much light sport, but the Helix and its developmental predecessor, the BlackFly, is an ultralight. It's
Ultralights.
yeah, it's a Part 103 aircraft. That is a space that is not very tightly regulated. It is regulated, and there are a lot of restrictions. There are some performance parameters and certainly weight parameters and occupancy restrictions and a long list of things you have to meet to actually be operating a ultralight. The company dedicated, the mission to going the ultralight route, single passenger, a long time ago, and I think in doing so, built the foundation for a strategy where the capital outlay to get operational, to actually set up some serial production, to actually have some customers, and to be flying a lot and learning a lot was just not over the top. It was a relatively small operation compared to any of the other kind of AAM participants out there, who many of them have spent billions already, and yet nobody has
Absolutely.
achieved a certification. Not one. I'm sure they're getting close. We've been hearing about getting close for a long time. They're charging up a very difficult and steep hill, which is a negotiated basis of certification with FAA, and going straight into commercial operations. That's a tough road to hoe. By staying recreational, short hop travel, private ownership, first in ultralight, in the future we'll get into other things, we're able to iterate and learn and make happy customers and deliver safe flight much earlier. And in doing so, test the market, build out the largest installed base of eVTOL aircraft that are all cloud connected, that after every single flight are pushing hundreds of megabytes of flight data and telemetry up into our data lake. And from that, we can infer everything from operator behavior to skill levels to unintentional inputs to predictive maintenance, performance trends. The list goes on and on and on. And as we're able to integrate more sensing, it will help us inform additional, full spectrum autonomy. The aircraft already has a fair amount of autonomy built into it.
It does, yes.
Yeah. So just the easy parts, where the aircraft's come into contact with the ground, the takeoffs and landings, just the easy stuff. But no, seriously, it makes it incredibly easy to learn and easy to use, at least initially. But ultimately, it does increase the training burden, because Every
Yeah.
competent operator needs to know how to fly when the autonomy is, for some reason or another, not working correctly. So you've got to teach them how does it work when it's, how does it work when you're flying manually, if you will. And so we're very rigorous about training. In the ultralight space, you're actually not required to have a medical or a pilot certificate. We require that you pass our 2 weeks nominally of training. It's all task based. We've had a couple individuals fly through it a little bit faster. They were, very experienced pilots on a wide range of aircraft. We've had a couple individuals who took a little bit longer to get through it. We've had at least one individual who said we had to have that discussion and say, this isn't for you. Well, it happens.
It happens, of course. Yes.
You want to make sure that you're putting people up in the air who are going to be,
Yeah.
safe and competent and have a good time, and have good things to say about it.
Yeah, and that's one of the brilliant point about what you guys are doing. For those of you who are not aware of FAA Part 103, it means that, and I'm really generalizing the topic here, that you and I can go do a little bit of a training, few days to a week or so, and then we can actually buy one and operate one in our own backyard. And of course, there are certain restrictions, but that means you can actually get going right now. You can go grocery shopping, or as the case is with one of your early adopter, Tim, who said he needed something to go 4 miles to his mailbox because in the winter it's downslope and icy. Well, of course, get an eVTOL, right? Brilliant.
Why
I mean,
not?
that is such a, I know, why not? Why not? It makes a lot of sense. His ATV, his quad couldn't do it. So go fly. I mean,
Well, he
is
had a
that
choice.
that's the point.
If the snow is not too deep, he could do it on an ATV and spend an hour going up and down the hill. Or if the snow is really deep, he could do it in his snowcat, or he could push his BlackFly out of his carport, his nice heated carport, fire it up, fly down, land in the snow, pick up his mail, fly back. And he's done
That'd
the
be
same
awesome.
thing with his close friends in the area that he can fly to. He's actually installed charging infrastructure at their homes. He has used it to go to the grocery store. But more than anything else, he uses it just to explore the just the beautiful natural world around him. And he's been Forest Service. He's a retired Forest Service employee, former Army, former Air Force PJ.
Hmm.
And he just loves the fact that he can get out in his aircraft, zip around, land somewhere, pay to visit, hop back in, go home. And he's covered, territory in a few minutes that would have taken him hours and hours to walk.
To walk. Yeah, absolutely. That makes a lot of sense. Um, we'll get back to the charging because I think that was something that I really enjoyed when I went out there. By the way, I did try the simulator and it was a hoot. And you're right, it is easy to fly. I'm not a pilot, but I understand enough that I could get myself in trouble in a real airplane. But in a simulator, I was flying up in no time. And also, just a word of encouragement to go on their website, go on their YouTube site, and go and see those videos. If that doesn't make you drool with envy, there's something really wrong with you. Check your pulse, kind of thing. But those videos are absolutely brilliant. I love them. Yeah, so before we get into the infrastructure side of things, tell us a little bit about, well, tell us about the Pivotal too, because you used to be called Opener, now you call Pivotal. What happened?
As a mostly inward facing, engineering and prototyping and serial testing entity, trying to mature this technology, this novel aircraft architecture, things like, branding and naming that had a little bit less importance as we wanted to move towards actually delivering to customers. Come to find that Opener is a fine name if you were in the kitchen gadget business, but if you want to kind of deliver transformational aircraft, it should probably be something a little bit different. So we actually did partner with a local firm, did an exhaustive name search. It took months. Now, I'm not the marketing expert, but it was a lot of beads of sweat on a few individuals' forehead to find what would actually work. There were many proposals that did not pan out because somebody had the domain, or there was some sort of other conflict, or it sounded strange in another language. And ultimately, we
Yes.
landed on Pivotal. And it was, double entendre with the transformational nature of the technology and maybe even the motion of the tilt aircraft eVTOL as it takes off and lands.
I know it was brilliant. When I first heard it, I was like, wow, nobody got that name. That's a no-brainer. I got electric air mobility about a year and a half ago. I was like, really? Nobody got that? So when I heard Pivotal, I thought, oh, that's brilliant too. And of course, going from BlackFly to Helix, that was beautiful because it goes really well with Pivotal. That's perfect.
I mean, black flies are lovely creatures, and as I've been told, they're quite disruptive. Um, but not
Come
everybody,
to
yeah, not everybody likes them. So the Helix is designed to be, the brand of this, single aircraft or single person aircraft for the masses, for those who want to really get out and enjoy the freedom of personal flight. It is transformational fly. I've been lucky enough to do a bunch of flights just in the past few weeks. Last week I was in Tampa and I was flying with one of our customers at the Special Operations Forces Week. It was only our second defense trade show. And typically at Soft Week in Tampa, they do this big capabilities exercise with, gunboats on the bay and
Yep.
helicopters and UH-60s and mini birds. And guys are rappelling or parachuting. They have power paragliders, Marine Special Operations and power paragliders. I guess there was a government travel ban, and they decided, well, we're not going to do that this year.
Oh, that's
So,
right.
and we were going to be participating in that. So that was a little bit of a disappointment. Then we continued to pull that string, had a discussion with Tampa Tower. We had clearance to fly. So we said, hey, there's no reason we can't fly. We asked for a temporary flight restriction for no UAS because, there's about 20 different drone vendors at this show. And we didn't want to be smacking into their drones that they're flying around the convention
Yep.
center. And we were told we didn't really have standing to request that. But the day before we arrived, come to find out, there was a TFR, no UAS in the area. It's like, this is great. It's just for us.
Lucky.
There were other motivations for having that. And actually the show management and the locals were all delighted to have us flying. They rolled out the red carpet for us at the Peter Onite Airport, which is about 3 miles to the south. And I think we flew 24 sorties in 3 days. It got very normal. It was just
Yep.
normal, and when we're flying over these canals in the Bay Area there in downtown Tampa. So there's no people over the waterways that we're flying over, but there's tall buildings to the left and to the right, which make it a unique experience.
Wow. So you have to promise me that if you're in Savannah and you have a client in Savannah, you're going to call me up because I want to see it up close and take some
I
nice videos of
love
it.
Savannah, and so it might not be in the middle of the summer.
No,
We'd love to be flying in Savannah tomorrow.
please, anytime. We're working on it. We're working on it. So I'm going to take one little break right now because I realized that I forgot something important. I have to show you that I always carry with me here. Not too far away for once. I'll edit this part out. Ta-da-dum!
Ah,
Still have it.
yeah, a little pre-printed BlackFly. I've got one of those on my desk too.
So I use this to explain to people when I'm on calls, how an eVTOL works. It's so helpful because you can easily show how it works, how it takes off, how it lands. And actually, now that I have this in my head, this is the one question I always forgot to ask you when I wrote articles is the shape is unique. It's absolutely unique. Do you any idea how they came up with that? Because nobody else does anything like the Helix.
That's true. Well, that actually isn't true. I'll walk you through it. It's the Helix. It's almost as like you started with the idea of a tail sitter, and then kind of stretched it and blended it in two axes. So tail sitters as eVTOLs or VTOLs generally have some controls challenges because you've got to come
Yep.
straight up vertically, and then somehow you got to make a 90-degree transition.
Boom.
And there tends to be kind of a dead band where you're not really in control of the aircraft. You're just flipping from one mode to another. The other big challenge that tail sitters have is landing in a crosswind.
Yeah,
So
that's a lot of resistance right there. Oh,
you're
yeah.
trying to land. If you're coming straight down, you can maybe turn sideways into the wind, so you get a minimum profile. But if you gust from this way, now you're more likely to pop over. If you've ever seen some of the videos of there's a ducted tail sitter called the Martin VBAT. It's a UAS. Navy loves these things. When it's landing on the back of a ship, they also send a seaman has to run out and kind of catch it if there's some winds and hold it down because it wants to fall over. This architecture does not suffer from that problem at all. You simply aim into the wind and you land. And there's absolutely no loss of control whatsoever. And you've got the full range of command authority through the entire range of flight, whether you're in hover or in cruise or everything in between. And that is unique. So the other aspect of the aircraft's architecture that I think it's incredibly important to get your head around is the idea that as a tilt aircraft eVTOL, it has no rotating motors. There's no motors pushing motors.
Nope.
So you can vary between vertical and horizontal flight.
True.
There's no rotating wings.
Right.
And all the complexity and moving parts and controls that go with those things, it's quite substantial. If you were to start counting the number of control surfaces you have on, say, a Joby or an Archer Midnight, they're magnificent works of engineering. I love them both.
Yeah, absolutely. Yeah.
But they're complex. Goodness. They are complex, and you'll probably stop counting in about the 40s. We have 12, and 8 of those are just RPM values. So that makes it substantially, unapologetically simple, quite frankly, and very robust and reliable. The lower your part count, the lower number of systems that can fail, the more reliable you are. The lower your part count, lower the number of moving parts. Also a huge cost benefit to that. There's also a huge mass benefit to that. So you bring all those together, and you've got a system that you can establish a robust safety baseline on in a lot less time, and actually be up and flying and enjoying it.
Yeah. Yeah, indeed. And those videos, you have to watch those videos because you can see how much fun it is. And I wouldn't have expected something like that to be that nimble, because your main guy there, I forgot his name. I met him. I apologize. I forgot your name. But he does some pretty wild, funny things. And I'm itching to get into one of them. I want to get into one of them so badly. Just watching those videos.
Yeah, it's a lot of fun to fly. The flight, kind of the range of operation that you have is intentionally a little bit limited by the software, to be a box that's inscribed within the box of known flight capability of the aircraft. The speed is software limited to 55 knots calibrated airspeed to comply with the Part 103 regulations. It really does want to fly a little bit faster. And that's been done in Canada, but not in the US. In Canada, it's flown as a registered aircraft in their ultralight category, which is a little bit different than what we have structured in the US. Yeah. And we're also looking at exporting the Helix in the relative near term, very shortly after our market introduction, and start to ship to customers, New Zealand and also Canada, and others to follow.
All right. Well, for the European thing, let me know, because I can help you guys with that easily. Tell us a little bit about the military. Why would the military be interested in a Helix?
Well, a Helix or certainly a derivative of the Helix, and you can certainly use the Helix as a capability demonstrator today, and that's a lot of what the Air Force has already done. So last summer, we delivered 8 aircraft to the Air Force, both at New Braunfels, Texas, and Springfield, Ohio. The aircraft were split between the two sites. Ultimately, they got their COA to be able to fly in Springfield, Ohio, and they did many weeks of non-developmental testing, looking at different missions that the type of aircraft could fulfill, whether it's for cargo delivery or disaster recovery, or delivering a messenger or a specialist or a doctor to a specific site. Self-rescue is something else that they looked at, and they wanted to understand, how fast does it fly, how far can it fly, what kind of surfaces can you land on, and operationally, how easy is it to support, and other things that were really important to them is, how quiet is it? And one of the things we learned after NASA performed an evaluation of the acoustics is that it may well be the quietest aircraft in manned flight when it's in cruise. And so, it does have kind of two distinct modes of flight. You're in the hover controller when you're taking off and landing and making that transition. That transition can take seconds sometimes if you're a really efficient pilot. And then in cruise flight, the first thing you notice is that the motors get very quiet. And in fact, the very first time as an operator you go into cruise, it might feel a little alarming. You're asking, did my motor just shut off? And I'm surging forward. I'm upright now. I can see the whole world. Am I about to go into a dive? No, you're not. It's actually amazing. And we typically train our pilots to fly between 250 and 400 feet above ground. And the reason for that is, well, number one, you use energy ascending and descending, and you only want to get so far away from the beautiful landscapes that you're trying to admire. Two, that gets you kind of out of the most dense bird band, if you will, and we all want to avoid bird strikes. And then finally, the aircraft does have a full aircraft parachute, ballistic parachute, just like a Cirrus does, and that is the if all else fails, there is this big red knob and a ballistic parachute that's there's a little self-test during pre-flight, make sure everything is working right. It's never been used except in all the extensive testing we've done, where it's been deployed at many different heights in many different modes of flight, with and in some cases with anatomically correct test dummies that are fully instrumented. To determine is there an opening shock, is there whiplash, what is the impact like when you finally land. And a lot of that testing informed some of the changes we made from the developmental vehicle, the BlackFly, as we went to the Helix to make sure it was a nice, slow, gentle set down when you land, that you're actually able to separate the aircraft from the parachute after you land, so you're not dragged if it's a very windy day. So a lot of development went into that, and we've tested it extensively. So, but again, to give that operator time to respond, should there be some sort of anomaly, unforeseen anomaly, but catastrophic failure, what have you, we train everybody to fly between 250 and 400, because you can fall a long way in two seconds.
Oh yes.
At any rate, at 250 feet, we're cruising over this entire airfield that's been instrumented with calibrated microphones by NASA, and they're having us fly back and forth. They've already evaluated the acoustics at the takeoff and landing and initial ascent and descent, and sheepishly asked us, "Could you please fly a little bit lower?" And we're like, "Well, what's wrong?" So said, "Well, except at one very narrow frequency, you're not really above ambient noise." So the crickets and the birds were a little louder than we were when we were flying at 250 feet for the most part. So we repeated the exercise at 100 feet and got them the data that they were looking for. And the good news about it is we still haven't really done anything to the aircraft to optimize the acoustics. So there's more levers we can pull still. And I would also add that it has a very, very minimal infrared signature. If it were to be flown at night and observed with night vision devices, you really wouldn't have a lot to see. It generally takes on the temperature of ambient air on almost every surface, unless it's being viewed from a very specific angle. So there's some utility to that from the military mission perspective, especially with a near-term mission we could fulfill. There would be covert insertion and extraction. You've got low observability.
That's true.
You've got low noise, and that's a mission that they could perform, pretty much now. Although this aircraft specifically is an ultralight, military services are not going to be bound by the ultralight rules. They could have a derivative of it that has maybe 12 motors instead of 8, using the same motor technology we have today, more packs, different wings. And now suddenly you've got something to fly twice the range, twice the endurance, and a little more payload. And the value of that, operationally becomes a lot more relevant. But one thing is clear before we are delivering anything that looks like, sort of meaningful volumes to our service members and supporting the warfighter, we're likely to be in the hybrid propulsion business.
Of course.
And we're actually cutting our teeth on that this summer. We have a tech demonstrator that's in process. The hardware in the loop is actually running today, and we expect that by the August timeframe, we will complete a remotely piloted 250 nautical mile flight with that aircraft in about 4 hours. It's not going to be fast, but neither is the Helix or the BlackFly. They tend to fly at speeds that are a little bit below typical rotorcraft. And in most cases,
not the point.
If stealth and efficiency is the name of the game,
that's
generally okay.
Wow, so many things that I'm gonna have to ask you to come back because there's so many questions that are popping up, and I have to go okay after, even also showing how it works and everything. But we only have 10 minutes left. Let's get to the why, or maybe more so to the who. I mean, Ken, why in the world are you doing this? What is wrong with you, a startup? That's one of the most difficult thing to do in this planet, or at least in this society.
Well, if I'd say if it were easy, everybody would be doing it. Years ago, I had the privilege of visiting JPL over decades ago, actually. And it's probably shortly after I started with AeroVironment. We've been doing some work with them on an ongoing basis. And there's a wonderful description right in the lobby there. And it says, "Dare mighty things." It's a lot more interesting life tale to have to try to do something that's a little on the challenging side, even if it doesn't work out. You can, advance the state of flight or of the human condition is ultimately what we're here to do. Because with mobility advances humanity, and you can tie those two together at every inflection point in history, whether it was the invention of the stagecoach, the rail, the automobile, or airliners becoming ubiquitous, which is where we are today. And overwhelmingly, that mobility has improved the human condition. And ultimately, what we'll be doing, I don't think it's a straight line from where we are today, or where anybody is today, frankly, to this widespread adoption of advanced air mobility, especially in urban areas. But as a civilization, we'll get there. And we're just on a slightly different path to get us there. Starting in the ultralight world and moving into, public safety and defense missions. And from there, who knows where we'll.
So very last closing thought, pivotal in 10 years. What are you guys doing? You know what? Crystal ball, like poof, magical pixie dust stuff.
I think that pivotal is uniquely positioned and supported to become a very significant player in the realm of advanced air mobility and advanced distributed electric propulsion technology that is solving specific business problems for defense, for public safety, and ultimately a widespread participant in the advanced air mobility ecosystem, but first focused on privately owned assets. And we think that the public and shared assets will get there too. I just think that'll take a little bit longer.
Yeah. And you know what? This is aviation, right? It takes its time. It's the way it is. So anyway, Ken, thank you very much. I hope to see you again and again on the podcast, The Ways We Move, where we highlight innovative forms of mobility and the people driving them. And just to talk about this neat, very unique looking eVTOL that I've always resonated with. Thank you for your insights. And for those of you watching and listening, please like, subscribe, and tell us your thoughts. Has AAM, your understanding of AAM changed? We'll make sure you know how to reach Ken and his team. And if you're ever out there, go and check it out. It's pretty cool. Will we see you in Oshkosh this summer?
You will not. We are actually waving off Oshkosh for the first time ever. We've gone every year for the last 5 years or something.
Absolutely.
We were at Sun and Fun a few weeks ago. We were at the Polo Fields in Miami. We were at Formula E. We were doing media capture flights over the Tampa Bay. We were at Soft Week. We were at Modern Day Marine. We've got a much broader diversity of events we're participating in all over the country. And, everywhere from, the Hamptons this fall to be leaf peeping in Michigan in October. So, go to our website, look us up. We're doing events all the time. It's not just Oshkosh anymore.
What's the website?
Pivotal.aero.
That's easy to remember. All right, folks. You heard it, and you will hear it again here. AAM is a reality. We'd love to hear your thoughts and comments. Like, subscribe, share, and then we'll see you next week again very soon. Thank you.
Thanks, Nicholas.